Okay, students. So we discussed the lesson. I am sure you have understood what atomic mass unit is, then the relative atomic mass, relative molecular mass, the relative formula mass, then Avogadro constant, molar mass and moles. So now we are going to practice calculating these values. So I am going to start off with the questions given in your grade 10 unit 7 textbook. So this is the exercise. The first question is to find the relative molecular mass of the following substances. So the substances are given here. CH3OH, that is methyl alcohol or methanol. CS2, carbon disulfide. C8H18, octane. CH3COOH, acetic acid. C12H22O11, sucrose. CONH2 twice, urea. C9H8O4, that is aspirin. HNO3, nitric acid. CCl4, carbon tetrachloride. C8H9NO2, that is paracetamol. Then the relative atomic masses, RAM, relative atomic masses are given to you. Hydrogen 1, carbon 12, nitrogen 14, oxygen 16, sulfur 32 and chlorine 35.5. So I am sure now you have already calculated these relative molecular masses. If you haven't done it, quickly calculate them and check your answer with my discussion. Now I will move on to the first question. CH3OH, that is methyl alcohol. So here carbon, I'll rewrite the formula CH3OH. So how do you calculate relative molecular mass? There is one carbon, so it's 12. Then hydrogen, you can see H3 and H. So there are 4 hydrogens. So 4 times 1. And there is 1 oxygen, 60. So then if we calculate the value, 12 plus 4 plus 16, that is 32. And you know there is no unit for relative molecular mass. So 16 and 16, 32. 32 is the relative molecular mass of methyl alcohol or methanol. Then the next one, carbon disulfide, CS2. So we need to calculate the relative molecular mass of CS2. What is that going to be? Carbon is 12. You were given all the relative atomic masses. So carbon 12 and sulfur 32, but there are 2 sulfur atoms. So 2 into 32. 12 plus 64, that will be equal to 76. Again, no unit. Then the next one, C8H18 octane. So here you can remember, students, the name oct is 8. So C8H18. We need to calculate the relative molecular mass. So now I am not going to rewrite the chemical formula because it's already there. What is the relative atomic mass of carbon? 12. And there are 8 carbons like that. Plus there is hydrogen, that is 1. There are 18 hydrogens. So when you multiply this, 12 into 8, 96 plus 18. So you get the value as 140. That is the relative molecular mass of octane. Then the next one, CH3COOH is acetic acid. So here to calculate the relative molecular mass of CH3COOH, first is carbon. Now how many carbons are there? You can see there are 2 carbons. Then there are 4 hydrogens and there are 2 oxygen. So then you have to calculate the relative molecular mass. Carbon 2 times 12 plus hydrogen 4 times 1 and oxygen 2 times 60. So that is going to be 24 plus 4 plus 32. So when you add these together, students, 24 plus 4 plus 32, the value will be 60. So if you take acetic acid, the relative molecular mass of acetic acid is 60. With that, I will move on to the next one. Sucrose, C12H22O11. So relative molecular mass for sucrose, again carbon is 12. There are 12 carbons. Then hydrogen is 1. Like that, there are 22 hydrogens. And you can also write them within brackets. That is more clear. And oxygen is 16. Likewise, there are 11 oxygen atoms. So here, if we calculate 12 into 12, 144, then you have 22, 1 into 22. So then there is 16 into 11, that will be 176. When we add them together, so it will be 342. The relative molecular mass of sucrose is 342. Then the next one, CONH2 twice, urea. So here, if we calculate the relative molecular mass of urea, how many carbons are there? There is only one carbon, one oxygen atom. And also, now if you take this part, NH2 twice, that means there are 2 hydrogen, N2. So there are 2 nitrogens, and now see there are 2 hydrogens there, H2. Like that, there are 2 molecules. That is what is important. When you are given a formula like this, CO NH2 component is there twice, that you know. So there are 2 nitrogen atoms and 2 into 2, 4 hydrogen atoms. So when you calculate the relative molecular mass, now from here onwards, I'm not going to multiply by 1. So carbon 12, oxygen 16, and also there are 2 nitrogen. So 14 into 2 plus there are 4 hydrogens, 1 into 4. So that is going to be 12 plus 16 plus 28 plus 4. So that will be 60. 60 is the relative molecular mass of urea. That is what you have to write there. Then the next one. This is aspirin. That is C9H8O4. You all know this is a medical compound, a medicinal compound, a medicine aspirin that has this particular substance, C9H8O4. So when you are calculating the relative molecular mass, you need to write carbon. Carbon is 12. So there are 9 carbons. You multiply that by 12 plus there are 8 hydrogens, that is multiplied by 1, and there are 4 oxygens, so multiply by 60. Then you get the value as 108 plus 8 plus there is 64. So if you add them together, 108. 108 plus 8 plus 64. That is 180 is the relative molecular mass of aspirin. Then the next one, HNO3. Now you all are very familiar with calculating the relative molecular mass. So here HNO3 relative molecular mass. Hydrogen, there is only 1. So 1. Nitrogen, relative atomic mass 14, only 1 nitrogen. Now there are 3 oxygens. So 3 times 16. 16 is the relative atomic mass of oxygen. So that will be 1 plus 14 plus 48. Then we will get the value as 63. That is the relative molecular mass of nitric acid, HNO3. So now are you getting everything correct? I am sure you are, because you know how to do this calculation. Count the number of each atom, multiply by the relative atomic mass and add them together. Then the next one, CCl4, that is carbon tetrachloride. 1 carbon, tetra means 4, 4 chlorine. So carbon tetrachloride. If we calculate the relative molecular mass for carbon tetrachloride, RMM. Normally students, if it is just one question, you will be writing it as relative molecular mass of carbon tetrachloride and doing it. But here we are practicing. So I am not going to rewrite the name of the compound. I just give the abbreviation RMM and do the calculation. So carbon, relative atomic mass 12, there is only 1 carbon, but there are 4 chlorines and the relative atomic mass of chlorine is 35.5. So when you add 12 plus 4 into 35.5, that would be 142. So when you add them together, it will be 154. That is the relative molecular mass of carbon tetrachloride. 154. Then the next one, C8H9NO2, that is the component present in paracetamol. You know what paracetamol is? Again, a medicine, a tablet that contains this particular compound. So, if we calculate the relative molecular mass for this. So, in all these students, you can see the number of each atom is given to you directly. So, there is no need for you to count. But you saw in some of the compounds, you have to count the number of atoms of each element. So, here there are 8 carbons into 12 plus there are 9 hydrogens into 1 and there is only 1 nitrogen. So, you can directly write the relative atomic mass of nitrogen 14 and oxygen, there are 2 oxygens, relative atomic mass of oxygen is 16. So, you multiply 2 by 16. So, this is how we write the equation to calculate. Why is that? I am sure you know. There are 8 carbons, relative atomic mass of carbon is 12. So, we need to multiply 8 by 12. Then there are 9 hydrogens and the relative atomic mass of hydrogen is 1. Then nitrogen, relative atomic mass 14 and only 1 nitrogen. So, you don't have to show multiplying by 1. Initially, I did that, but then I told you no need to show. Then here, oxygen there are 2 and the relative atomic mass of oxygen is 16. So, when you do the calculation, 8 into 12 is 96. Then plus there is 9, 9 into 1 is 9, 14 is there and 2 into 16 is 32. So, here when you add them together, it will be 151. So, 151 is the relative molecular mass of paracetamol. So, I am sure you were able to calculate all these values, the relative molecular masses of the different compounds given to you. So, the only thing you have to really look at is if you are given the formula like this, directly you know the number of atoms of each element. So write that, multiply by the relative atomic mass. Otherwise, if you are given the complete formula, you have to count and check how many atoms of each element are present. And then you do the calculation. That's the simple difference when you do the calculation. So with that, I will move on to the next question. Find the molar mass of the following compounds. Now here the question says molar mass. Don't worry, the calculation is the same, but what are we calculating? Molar mass. Mass of 1 mole of substance. So what is that? That is equal to the relative atomic mass or relative molecular mass with the unit grams per mole. Mass of 1 mole of substance. So that is what we are going to do now. The compounds given to you are CO2, carbon dioxide, then NaCl, sodium chloride, CaCO3, calcium carbonate, NH4Cl, ammonium chloride, Mg3N2, magnesium nitride, H2S, hydrogen sulfide, AlCl3, aluminium chloride, NH4 twice. Now here you can see again NH4 twice CO3, ammonium carbonate, CuSO4, copper sulfate, Na2C2O4, sodium, this part is oxalate, sodium oxalate. And here again the relative atomic masses are given to you. Hydrogen 1, carbon 12, nitrogen 14, oxygen 16, sodium 23, magnesium 24, aluminium 27, sulfur 32, chlorine 35.5, calcium 40, and copper is given to you as 63.5. So use these values to do the calculation. I will start with the first one. I am sure you have already done the calculations. So then the first one, carbon dioxide. So here molar mass. So molar mass of CO2. What do we do here? Again carbon, relative atomic mass 12. Plus there are 2 oxygens and the relative atomic mass of oxygen is 16. But all these together will have the unit grams per mole. That's why it is the molar mass. So you have to write the unit. 12 plus 32. So that is also grams per mole. That will be equal to 44 grams per mole. Students, it is not compulsory to write the units in these 2 steps. But here when you give the answer, you have to write the unit. But what I do is, when I substitute itself, I write the unit. And with the calculation, so that the chances of making mistakes is less. So remember that. If you substitute with the unit, it's good for you. Less chances for you to make a mistake. But you have to write the unit here. Here the unit is important. So if they ask you for molar mass, if you don't write the unit, if you just do the calculation correctly and write it as 44, that's not correct. Because that is the relative molecular mass, not the molar mass. Molar mass has a unit. Remember that. So then I will move on to the next one. NaCl. Here what is it? It's actually the formula mass that you are going to calculate. But they have asked for the molar mass. So formula mass with the unit. What is sodium? Relative atomic mass 23 plus chlorine 35.5. And what is the unit here? Grams per mole. So when you add them together, it will be 58.5 grams per mole. That is the unit. You know why I leave a space here. That is how you are supposed to write the units. Between two units, you need to have a space. So then, the next one, calcium carbonate. So again, molar mass of calcium carbonate. What is the relative atomic mass of calcium? You can check it. It's 40. So there's only one calcium, then only one carbon. You know the relative atomic mass is 12. Then for oxygen, there are 3 oxygens. And what is the relative atomic mass? It is 16. So then what you do? I, of course, will write the unit as well. It is easy for me. So then again, we need to calculate the value. 40 plus 12, and here this is 48. So when you add them together, you will get the value as 100 grams per mole. That is the molar mass of calcium carbonate. Did you get it correctly? I am sure you did. And did you write the unit? Yes. So then the next one. NH4Cl, ammonium chloride. So here look at the name, ammonium chloride, because it is in the iron form. You can remember that NH4 plus iron and Cl minus iron, ammonium chloride. So if we calculate the molar mass for ammonium chloride, molar mass equals what? Ammonium, there is 1 nitrogen, relative atomic mass 14, plus hydrogens, there are 4 into 1 by RAM, that is relative atomic mass is 1, 4 into 1, plus 35.5. And as I told you, I will write the unit, gram per mole. So again, when we calculate 14 plus 4 plus 35.5 grams per mole. So what is the value? 53.5 grams per mole. NH4Cl, ammonium chloride, the molar mass is 53.5 grams per mole. Yes. So then I will move on to the next one. Magnesium nitride. NITRIDE. Mg3N2. That is magnesium nitride. So if you calculate the molar mass for magnesium nitride, here you can see magnesium. There are 3 magnesium atoms. And what is the relative atomic mass? It is 24. Then nitrogen, there are 2 nitrogens. We have to multiply by 14 relative atomic mass. And that is equal to grams per mole. The whole value. So here it is going to be 72 plus 28 grams per mole. That will be equal to 100 grams per mole. Repeat, molar mass of magnesium nitride, 100 grams per mole. Is it clear to you now? When you keep on practicing, you get a better understanding. You can do it faster. So then we will move on to the next one. H2S, hydrogen sulfide. This is a gas. H2S gas, hydrogen sulfide. It gives a very uncomfortable, pungent smell. H2S. So, molar mass of H2S. What do we do? There are 2 hydrogens. That has to be multiplied by RAM1. And plus there is sulfur, that is 32. That will be grams per mole. So here 2 plus 32, that is 34 grams per mole. So as I told you all students, you can leave out the units here or here. It's not compulsory to write it there. But here with the answer, you have to give the unit. I'm reminding you again and again so that you practice it now itself. Always for calculations, if there is a unit, you have to write the unit. That's very important. And the correct unit has to be given. So 34 grams per mole is the molar mass of hydrogen sulfide. Then I will move on to the next one. AlCl3, that is aluminium chloride. So here what is the relative atomic mass of aluminium? We need to find the molar mass. To do that, aluminium, it's 27 and chlorine is 35.5. So what do we do? 27 plus 3 times 35.5. That is grams per mole. So here 27 plus 106.5 grams per mole. That will be equal to 133.5 grams per mole. So, did you do it correctly? Yes. So, then I will move on to the next one. The next one is ammonium carbonate. Now, here again you can see ammonium is within brackets. That means there are 2 ammonium ions. So, how many nitrogens? 2 nitrogens and 4 into 2. There are 8 hydrogens. In one NH4, there are 4 hydrogens. Like that, there are 2 NH4 components. So, 8 hydrogens, 1 carbon and 3 oxygen atoms. So, those are the atoms present in that molecule. Then we need to calculate the molar mass. Nitrogen, there are 2. So, what is the RAM? 14. 2 into 14 plus hydrogen, there are 8 into 1. Then carbon, there's only 1. So, 12 is the relative atomic mass. You write that there. Then what do we do? There are 3 oxygens. So, 3 into 16, the relative atomic mass of oxygen. Here, I am not going to write the unit there. I will write it at the end. So, then it becomes 28 plus 8 plus 12 plus 48. So, when you add them together, 96, what is the unit? Grams per mole. So, like this also you can do. You don't have to show the unit at each step. But finally, when you give the answer, you have to write the unit. 96 grams per mole is the molar mass of ammonium carbonate. With that, I will move on to the next one. Copper sulfate, something we use commonly in the lab. You can remember for some of the tests we use copper sulfate. it has a blue color, a blue colored solution, hydrated copper sulfate, or the solution itself is blue color. So how do you find the molar mass? If you can remember, copper is 63.5 and sulfur 32 and oxygen is 16. Those are the relative atomic masses of these elements. So here, to calculate molar mass, we need to have 63.5 plus sulfur 32, but there are 4 oxygen atoms. So 4 into 16. All that will have the unit grams per mole. Now I am sure you are also writing the unit with each step. That's very easy. So 63.5 plus 32 and 64. You can even skip this step. If you can do maths very well, I am sure you can. You can directly calculate the value and write it. So here the value will become 159.5 grams per mole. So those are the molar masses of different substances. Copper sulfate, when you calculate, you get the value as 159.5 grams per mole. I am sure you were able to calculate all these. Now, are you all clear with the way we should calculate the molar masses? You need to know the chemical formula or the molecular formula. Then you need to know the relative atomic mass. According to the number of atoms of each element, you multiply the relative atomic mass, add them together, then you will get the value. But when it is molar mass, you have to give the unit grams per mole. That is the calculation. So then, sodium oxalate, Na2C2O4. C2O4 is oxalate, Na is sodium, so the compound is sodium oxalate, Na2C2O4. Sodium is 23. Carbon you know is 12 and oxygen is 16. So for molar mass, what do you do? There are 2 sodium atoms. So 2 into 23. Plus there are 2 carbon atoms. So 2 into 12. And there are 4 oxygen atoms. So all of these together have to be added. 46 plus 24 plus 64. What is the unit? Grams per mole. So then when you add them together, 134 grams per mole. That is the molar mass of sodium oxalate. This is sodium, this is oxalate. I am sure you were able to do that as well. Then the next one. This is the third question. What is the amount of substance in moles in 12 gram of magnesium? What is the amount of substance in moles in 10 gram of calcium carbonate, CaCO3? How many molecules are there in 5 mole of carbon dioxide? How many water molecules are present in 4 mole of water, that is H2O? What is the mass of 2 mole of urea, that is CONH2 twice? So those are the questions. I am sure you have the answers with you. Now we will discuss the answers. The first one. What is the amount of substance in 12 grams of magnesium? So first, for this calculation, you need the relative atomic mass, that is equal to 24. It is given to you in your textbook. So if you are using it as the molar mass, it has to have the unit. So molar mass of magnesium, what is the difference? You have the value, the same value 24, but you have the unit grams per mole. Then what do? Now you are supposed to calculate the moles in 12 grams of magnesium. You know the equation. What do we write? Number of moles equals mass of substance divided by the molar mass of substance. So for this first calculation, I am going to write everything. If you give this in symbol form, how do you write? N for moles, mass is going to be simple M, and molar mass is capital N. So this is going to be the equation. Then we need to do the calculation there. So the number of moles in 12 grams of magnesium. So what is the mass? 12 grams. What is the molar mass? We have written it there. 24 gram per mole. So the gram and gram will cancel off. Moles will go up. Before that, 12 divided by 24, that is 1/2 mole. So if you simplify and write, it will be 0.5 moles. When you take the mole minus 1 up, I am sure you are very good in maths, it becomes moles. So that is another convenience. When you substitute with the units, when they cancel off, you get the correct unit, means you have substituted the correct way. So that is a way of checking whether you have done the calculation correctly. But if you write the wrong values, you might make a mistake. But with this, you can confirm it to a certain extent, whether you are doing the correct calculation. So 12 grams of magnesium divided by 24 grams per mole, you will get the answer as 0.5 moles. Number of moles in 12 grams of magnesium. Then the next one. What is the amount of substance in moles in 10 gram of calcium carbonate? So the same thing, you need to calculate the number of moles of calcium carbonate. To do that, what do you need to know? You should know the relative atomic masses, or actually the molar masses. Calcium is going to be 40, carbon 12 and oxygen 16. Again, this is given in your textbook. You have that table where you have the relative atomic masses. So to calculate the number of moles, you can either write it as the equation mass over molar mass. I am writing it shorter. Or you can write the equation N equals M over M. So here, what this is, or you can use that. So what is mass? It's given to you 10 grams. What is the molar mass? Since you know the values, you know to add them together. Calcium 40, carbon 12 and oxygen 3 times 16. The unit is grams per mole. So here you will get the value as 10 gram over 100 gram per mole. So when you calculate, what do you get? That is going to be 0.1 moles. Why again? These two cancel off. Mole goes up. 10 over 100, 0.1. I am sure you were able to do this. So here students, You can either do the calculation here or you can do the calculation first and then you substitute it here. That is also okay. So I will just show you all that method. It's the same thing, only thing where you do it first or the order of the calculation. So you can first calculate the molar mass. This is the second way of doing it. Molar mass of calcium carbonate. So that we have already done. Before also we did calcium 40, carbon 12 and 3 times oxygen 60 grams per mole. So that is equal to 100 grams per mole. You can write this first and then you can do the calculation. N equals mass over molar mass. So here directly you substitute. Mass is 10 grams, molar mass is 100 grams per mole. So the answer will be 0.1 mole. So can you all see the difference, students? Here I have calculated the relative molecular mass, that is molar mass first. So 100 grams per mole has been calculated. So you substitute it directly. Or here you can do that calculation also in the equation. Both are same, no difference, just the way you do it. If this is easy for you, you stick to this method. If this is easier, you use this method. But in both instances, you have to show that you are calculating the molar mass of calcium carbonate. Unless they give you the molar mass of a compound directly. Otherwise, you have to show the working. This has to be shown. You can't do it somewhere else, directly substitute and get the answer. You have to show the working as well. I'm sure you know that. Then I will move on to the next one. How many molecules are there in 5 mole carbon dioxide? So now we are talking about molecules. Then you know we have to relate it to another constant. What is that? Avogadro constant. What is the value? 6.022 into 10 to the power of 23. So that is what we need here. Avogadro constant. That is equal to 6.022 into 10 to the power of 23. So what do they want us to find? The molecules that are present in 5 mole of carbon dioxide. So in 1 mole of carbon dioxide, there are 6.022 into the 10 to the power of 23 molecules. CO2 molecules. That is the meaning of Avogadro constant, no? I'm sure you can remember that. Do you remember? Of course. So then in 5 moles of carbon dioxide, how many molecules will be there? 5 into 6.022 into 10 to the power of 23. So that is going to be 30.110 into 10 to the power of 23. What do we do after this? We rearrange it to the standard format. So 3.011 into 10 to the power of 24. You have to look at the powers. The power changes. Is this correct? Do you understand it? Here I have written the value for Avogadro constant. I have shown you 1 mole, all just to recall what we have done before. If you show this, that is more than enough. So Avogadro constant is that 6.022 into 10 to the power of 23. The number of constituent units or building units present as there are carbon atoms in exactly 12 grams of carbon 12 isotope. That is the meaning of Avogadro constant. So if you take 1 mole of carbon dioxide, there will be 6.022 into 10 to the power of 23 carbon dioxide molecules. But the question is to find the number of molecules in 5 moles of carbon dioxide. So 5 into Avogadro constant. So 5 into 6.022 into 10 to the power of 23. You get the answer as 30.11 into 10 to the power of 23. When you rewrite it, 3.011 into 10 to the power of 24. What are these? Carbon dioxide molecules. That is the number of CO2 molecules present in 5 mole of CO2. Is it clear to you all now? Then I will move on to the next one. How many water molecules are present in 4 moles of water? So now we don't have to write everything again. You know what to do. So 1 mole of water has 6.022 into 10 to the power of 23 water molecules. So we need to find for 4 moles of water. Contains 4 into 6.022 into 10 to the power of 23. So that is going to be 54.088, the point is, into 10 to the power of 23. So that can be written as 2.4088 into 10 to the power of 24 H2O molecules. So that is what you were asked to calculate. How many water molecules are present in 4 moles of water? In 1 mole of water, there is Avogadro constant 6.022 into 10 to the power of 23 water molecules. So in 4 moles, you have to multiply by 4. Then you will get the answer as 2.4088 into 10 to the power of 24 water molecules. I am sure you were able to do that. Then the next one. What is the mass of 2 moles of urea? So again, the same equation, but you need to calculate the mass. So what is the equation you need to use? Mole equals mass over molar mass. It has to be MOLE. MOL is the unit. Mole equals mass over molar mass. That is N equals M over capital M. So here the moles are given to you, 2 moles. We don't know the mass. I will keep it as M. We need the relative molecular mass, or what is it that we need? The molar mass, that is M. So what can we do? We can substitute here and calculate, or I told you all you could have calculated it before. So here I will do it in the equation itself. How many carbons? Only 1. So 12 plus oxygen 16. The relative atomic mass is 16. How many nitrogens are there? There are 2 nitrogens. So 2 times 14. How many hydrogens are there? We have already calculated 2 into 2, 4 hydrogens. So when you add everything, you will get it as 60. What do we have here? we need to have the unit grams per mole. So 60 grams per mole. Then if you rearrange the equation, so from this 2 moles into 60 gram per mole is the mass of urea. So what is this going to be? 2 into 60. So it's 120. You can see the mole and mole minus 1 cancel off. You get the unit as 120 gram. So mass of urea. That is what we had to calculate. What is the mass of 2 mole of urea? It's 120 grams. With that, I will move on to the next one. That is the 4th question given in your textbook. How many moles of oxygen atoms, that is O, does 1 mole of each of the following compounds contain? You know the way to answer this question. I will show you. So the first one, aluminium oxide. Now how many oxygens are there? If you look at one molecule, you can see the formula Al2O3. So that means you know in one molecule of Al2O3, there are 3 oxygen atoms. So again students, you don't have to write this for your answer because it's the first one in the exercise. I am doing it in detail. What do you need to find? You need to find the number of moles of oxygen. So what is that equal to? Now in one molecule there are 3 oxygen. So in 1 mole of aluminium oxide there will be 3 moles of oxygen. That is what you need to find. So count the number of oxygen atoms. There will be that number of moles in 1 mole of the compound. So in 1 mole of aluminium oxide there are 3 moles of oxygen atoms. Is that clear? Then the next one, carbon dioxide. Now you know there are 2 oxygen atoms in 1 carbon dioxide molecule. So how many moles of oxygen are there? There are 2 moles of oxygen atom. That is how you calculate 2 moles of oxygen atoms. Then the next one, Cl2O7. How many oxygen atoms are there? There are 7 oxygen atoms. So in 1 mole of Cl2O7, there will be 7 moles of oxygen atoms. So that is how you do the calculation. Then the next one, CH3COOH. What is this? This is acetic acid. How many oxygen atoms are there? Here you can see 2. So we can say in 1 mole of CH3COOH, there are 2 moles of oxygen atoms. Did you get it correctly? I am sure it's very easy, so you would have got it correct. Then barium phosphate, Ba3PO4 twice. Here you have to look at these 2. O4 twice. So how many oxygen atoms? 8 oxygen atoms. So in 1 mole of barium phosphate, Ba3PO4 twice, there are 8 moles of oxygen atom. Is it clear to you now? Yes. So students, with that, I have come to the end of discussion on the exercise given in your textbook. So now you know to calculate different things. You know if you are given the chemical formula, you know to calculate the relative molecular mass or the molar mass. Then using the chemical formula and calculating the molar mass, if you are given a sample with its mass, you can calculate the number of moles. The same way, if you know the number of moles of substance, you know to calculate the mass of the substance. Then you know to relate moles to Avogadro constant and then find the number of atoms or molecules. And also you know to find the number of moles of atoms in different amounts of compound. So that is different moles of compounds. So those are the ways you will need to do calculations in this lesson. So with that, this discussion is over. In the next chapter, I'll be discussing some extra questions with you all.